Dear students, today I will discuss with you some important MCQ from the chapter solution. Okay, first question: which of the following aqueous solution has the highest boiling point? Okay, highest solution has the highest boiling point. So these are the solutions given. So question number 1. These are solution given: 0.1 molar KNO3, 0.1 molar sodium phosphate, 0.1 molar barium chloride, 0.1 molar potassium sulfate. So here you see, if the number of ions is more, in which case number of ions are more, that will give you the highest boiling point, because the molarity is same. So highest boiling point you see here, Na3PO4, 4 ions you will get, Na3, that is 3 Na plus you will get, and 1 PO4 minus 3. So 4 ions you will get. So choice B is the correct answer. Next, which one of the following electrolyte has the same value of Bantoff factor, that is I, as that of aluminum sulfate? Okay, if all are 100% ionized, same procedure, where here you see the number of ions 2 plus 3, that is 5 ions. Question number 2, 5 ions, Al2SO4. okay, so you will get Al2SO4, that is 5 ions you are getting. Okay, similarly, where you are getting the 5 ions, okay, where you are getting 5 ions, you see K2SO4, it is 3 ion, K3FeCN. okay, here you will get 3 plus, and this is 1 minus 4, and here is also you are getting 3 and 1 aluminum, that is 4, and here you are getting 4K plus, and this one is minus. So you are saying it is equivalent to this one. So choice D is the correct answer. Next, the correct equation for the degree of association alpha of an associating solute, n molecules of which undergoes association in the solution, is what? So it is association. Okay, so question number 3, you see degree of association. You see, let us take question number 3. Let us take Na acid, it dissociates as An. Okay, so it is 1 mole you are taking, starting 1 mole. After some time 1 minus alpha will be remain, and associated amount is alpha by N. Okay, so total number of ions is equal to 1 minus alpha plus alpha by N. Okay, that is I is also Bantoff factor. I is equal to 1 minus alpha plus alpha by N. Okay, so now our function is to solve this one. Okay, so you see 1, this implies 1 minus, you take alpha is common, and 1 plus 1 by N. Okay, this implies 1 minus alpha N plus 1 by N. Okay, and this is equal to your I. Okay, so now our function, our duty is to take I minus 1, you take 1 to that side, I minus 1. Okay, I minus 1 is equal to your what? I minus 1 is equal to minus alpha N plus 1 by N. Okay, this is the case. So then alpha is equal to, you say alpha, therefore alpha is equal to what you will get? N I minus 1 by alpha is equal to minus of N plus 1. Okay, this much you are getting. So now minus 1 minus is there, so you can say n into I minus 1. So this minus brings u here, so 1 minus n. Okay, so this is the, so you see alpha is equal to n into I minus 1, n into I minus 1, 1 minus n. So this is the, this choice is the correct answer. Okay, these are very simple questions. Next, the molar mass of the solute sodium hydroxide obtained from the measurement of osmotic pressure of its aqueous solution at 27 degrees centigrade is 25 gram mole inverse. Therefore, its ionization percentage in this solution is what? So these are the choices given. We will do. Okay. So what is given? 25 gram aqueous solution, 25 gram per mole is given. So measurement, it is measurement. So you see, what is I? Van Tau factor I is equal to, question number 4. I is equal to normal or calculated molecular mass. It is known as normal or calculated molecular mass divided observed molecular mass. Observed molecular mass. Okay, this is known as Van Tau factor. So how can you remember? You should not get confused. How can you remember? See, first n is coming in the alphabetic, first n is coming or C is coming, then after this O is coming. Okay, so normal or calculated divided observed, that is Van Tau factor. Okay, so your normal for sodium hydroxide, it is 40, okay, molecular mass, and the observed is 25 gram per mole, so 25. So you will get the answer 1.6. Okay, the Van Tau factor, this is 1.6. But when sodium hydroxide dissociates, it will give you Na plus and OH minus. Okay, so initial, let us say it is 1 mole. Okay, after some time 1 minus alpha, the alpha amount is dissociated. Okay, so I, the Van Tau factor I is equal to 1 plus alpha. Okay, so what is 1 plus alpha? I is equal to 1 plus alpha. So total, this means alpha is equal to I minus 1. Okay, so what is I? What is I? I is equal to 1.6. I is equal to 1.6 minus 1 is equal to 0.6. Okay, so 0.6, you are getting the 0.6, that means 60% of, therefore its ionization percentage in this solution is 60. Okay, as I is equal to, alpha is equal to 60%, you are getting alpha is 60%. What is alpha? Alpha is the degree of dissociation. Okay, so therefore it is 60%. Okay, so choice B is the correct answer. Next, 1 gram of monobasic acid in 100 gram of water, 100 gram of water lowers the freezing point by 0.168 degrees centigrade. If 0.2 gram of the same acid requires 15 ml of n by 10 alkali for complete neutralization, the degree of dissociation of the acid is how much? So Kf is given 1.86 Kelvin kg mole inverse. Okay, now we'll do. So see, question number 5, the same procedure you apply. Question number 5, you see question number 5, what to do? Molecular mass of the acid, M2, it is the calculation. So what we are taking the formula? 1000 multiplied Kf multiplied W2 by W1, then delta TF. Okay, so you put all these things, 1000 multiplied Kf 1.86 is given, multiplied your 1 divided 100 multiplied 0.168. Okay, so after calculation you will get 110.7. Observe, it is observed molecular mass. Okay, observed molecular mass. Okay, then the next phase is your 15 ml. 15, what is given? 15 ml of n by 10. 15 ml of n by 10 alkali neutralize acid is equal to 0.2 gram. Therefore 1000 ml of 1N alkali will neutralize how much? 0.2 divided 15. It is given 15 or 15.1. See, so you are taking this and 15 multiplied 1000 multiplied 10. Okay, because you are taking 1N for 1N, so the value you will get that is 132.45 gram. Okay, so this is your what? One is you are taking for 1000 1N alkali, so it is neutralization, that it means it is your equivalent weight. Okay, so it is your equivalent weight. Okay, but it is taken as a monobasic. So monobasic, your formula, if monobasic valency is 1, for monobasic valency is 1, therefore molecular mass is also what? 132.45 gram. Okay, so I is equal to Bantow factor I is equal to 132.45 divided 110.71. So by doing this you will get 1.196. Okay, so as it is monobasic acid, HA monobasic acid, it dissociates H plus and A minus. So initial concentration 1 mole. After that sometime 1 minus alpha will dissociate as acid and okay. So total I is equal to 1 plus alpha. Understand? So what is I? I is 1.196. Okay. See, I is equal to 1.196 is equal to 1 plus alpha. Okay. Therefore alpha is equal to 1.196 minus 1 is equal to 0.196. Alpha is 0.196. That means percentage of dissociation is equal to 19.6%. What is alpha? Alpha is degree of dissociation. So out of the choices, which one is correct? Which one is correct? Your B choice is correct. Okay. Next, see question number 6. 0.6 ml of acetic acid is dissolved in 1 liter of water. The value of Bantow factor is this much. What will be the degree of dissociation of the acetic acid? Okay, this is very simple. You take acetic acid, question number 6, CH3 COH, it dissociates as CH3 CO minus plus H plus. Okay, so initial concentration 1 mole, it is 0 and this is 0. So after some time 1 minus alpha will remain. Here alpha is dissociated. Okay, so I is given 1 plus alpha. Okay, but what is I is given? 1.04 is equal to 1 plus alpha. therefore alpha is equal to 0.04. Okay, so out of the choice D is the correct answer. Next, the boiling point of 0.2 mole kg inverse solution of X in water is greater than equimolar solution of Y in water. Which one of the following statement is true in this case? Okay, so out of the choices, you see which one, that is the equimolar solution. If two equal solutions are given, for equimolar solution of water, two substance of the substance, then one that undergoes dissociation produces more ions, and the solution has the highest boiling, greater boiling point. More ions. Which one is giving more ions? So according to your the choice, C is the answer. X is undergoing dissociation in water. X is undergoing dissociation in water. Next question. Question number 8. You see, the freezing point in degree centigrade of a solution containing 0.1 gram of this complex, molecular weight 329 in 100 gram of water, Kf is given this much, is what? You see, question number 8. Okay, what is the complex? The complex is K3FeCN6. Okay, so you are getting it dissociated as 3K plus FeCN6 3 minus 3. Okay, so here number of ions is 4, ion number is 4. Okay, so delta TF is equal to IKF and molecular mass. Okay, so I is equal to, then I multiplied KF multiplied by M into 1 by W1 into multiplied 1000. Okay, so 4 multiplied KF 1.86 multiplied 0.1 gram and 329 molecular mass 1 by 100 into 1000. So by solving, you will get the answer, you will get, that is 0.023. What is given? 0.023. So you can take this 0.023 into as 2.3 multiplied 10 to the power minus 2. Okay, therefore then TF is equal to 0 minus 2.3 multiplied 10 to the minus 2, that is minus 2.3 10 to the power minus 2. This much degree centigrade. So out of the choice, A is the correct answer. Okay, you understand this? Again I am repeating, you take this complex, you dissociate this one, I number of ion is 4. So this is the formula, delta TF is equal to Van't factor KF and M. So in the place of M, you are putting all these things. Okay, so 4 You are taking what? 4 multiplied all this, putting all these things, and you are getting 0.023. So this 0.023 is equal to 2.3 multiplied 10 to the minus 2 degree centigrade. So TF is equal to, okay, TF is equal to 0 minus, because it is the freezing point. 0 is the freezing point. So it is the difference. TF is the difference. So 0 minus this much, okay, this much. So you will get this one, okay. Next, question number 9. The Vanto factor for BaCl2 barium chloride at 0.01 m molar concentration is 1.98. Okay, it is taken as 1.98. Okay, the percentage dissociation of barium chloride at this concentration is how much? See, question number 9, how to do. Barium chloride is given. Barium chloride, it dissociates Ba plus 2 Cl minus. Okay, so it is initially 1 mole. After some time 1 mole changes to alpha, 1 minus alpha. So here alpha, and it is 2 alpha degree of dissociation. Okay, so total 1 plus 2 alpha. Okay, 1 plus 2 alpha. So that is I is equal to 1 plus 2 alpha. Okay, so alpha is equal to, I is equal to alpha. Therefore alpha is equal to how much? I minus 1 by 2. Okay, so what is I? I value is given. I is 1.98. 1.98 minus 1 by 2, that is 0.98 by 2, that is 0.49. Okay, so degree of dissociation percentage, that is 49%. Okay, so choice A is the correct answer. Next, the Vanto factor for dilute aqueous solution of the strong electrolyte barium hydroxide is how much? You see, here the number of ions is 3, so answer D is the correct answer. Okay, okay students, have a good day.